All right, guys, what's up? Welcome back to part 2 of buffer overflow, Windows buffer overflow. Definitely what you need to know for OSCP type of video. If you haven't caught part 1 of this video, I'll link it in the description below, so be sure to check that one out first. We covered all the way up to the finding bad characters. So we already identified that the Overflow 1 parameter is vulnerable to a buffer overflow attack, and we saw that we were able to control the EIP register, the instruction pointer. So using that, we should be able to root this box or get a shell on this box, I should say, get code execution, so long as we are able to find a jump ESP instruction that doesn't have the proper protections on it, which we'll be getting to that and much more in this video. And so the next part is to identify the bad characters. Now, what does it mean by bad characters? Basically, all that bad characters are characters that have some kind of a special meaning to the program. So, for example, one pretty much universally bad character on pretty much anything is the null byte. And all these characters are represented in hexadecimal. That's how we work with them when it comes to buffer overflow. We normally just represent them in hex, and that's what this \x means. It means that the character should be interpreted in hexadecimal. And so this character here is 00. This is the null byte. It's often used as a string terminator to close out a string. But basically, you have all kinds of hex characters. Basically, 00 all the way to FF is the highest, right? There's 256 of these total. And each hexadecimal representation, it represents a different character. So basically, we just need to generate a string of every single possible hexadecimal character there is. And this Python script will allow us to do that. And we're going to use Mona and pass in the bad characters into this byte array. And basically, it's just going to compare with their byte array bin to see if any of them are bad, right? And it'll tell us which ones are the bad characters. So if you're using, if you're doing a Windows buffer overflow, it's really nice. You can use Mona to do this, and you can compare it here as you see the byte array bin to your the characters that you passed in. So what we're gonna do is we're just gonna step through and do this. So first, let's just generate a string of all the potential characters that we could use. Because when we generate our payload, the big picture here is when we generate our payload, we want to make sure it doesn't have any characters that have special meaning to the program. So all of our characters are interpreted how we want them to be interpreted and not in some other way. So we're going to avoid any characters that have special meaning. And first, we got to identify what those are. So what we can do is I can come over here. We can go ahead and create another file. We'll call this badchars.py. And I'm going to need to give ownership to my user here. Let me do that really fast. And now we can come here. We can just paste that in, this little script. And when we run it, we should see a list of all the hexadecimal characters from... We're assuming 00 is a bad character, so we're not even including it in the list. Just something to note here, but we're basically from 01 to FF. And so I can copy that and put that in as our, I believe as our payload, right? Yep. Put that in as our payload. And now what we're going to do is we can run, we can generate our byte array because we haven't done that yet, and just say, hey, the null byte is a bad character. So I'll come down here, run this, and you see that output saved in Mona OSCP byte array.bin, and you can see the text file version of it. It's byte array.txt, and you see basically everything except 0, 0 because we said with the -B flag that 0, 0 is a bad character, so therefore it was not included in this list. So that is all as we intend here. And so now what we're going to need to do is, we did this part already. So now we can restart this this program here and just run the exploit script against it. So let's do exactly that. So file, open, and run this. And like I say, I like to verify connectivity first. Let's go up arrow here. And yep, it works. So now we will run the exploit against it. And so upon doing that, we see we have, in fact, crashed the program again. And, you got your 42s and EIP, but most importantly, we need to run this compare Mona module against it, Mona script or module, whatever it is. And so we want to make a note of what the stack pointer register is in this case, and that's going to help us determine which character was bad. So ESP here, this is the, I'm going to copy this value. And so can do that. And then we'll run this compare. This Mona compare right here. And that's when it comes up here with a list of potential bad characters. Now, in a second, you'll get to why I'm calling these potentially bad characters. Let's use Notepad here to just help us out with this, so we know. So we got null byte, we got 07, 08, 2E, 2F, A0, and A1. But the reason I say potentially bad characters is it says here, that not all of these are necessarily bad characters. Sometimes bad characters cause the next byte to get corrupted as well, or even affect the rest of the string. Okay? So what it means is, for sure this is a bad character, for sure this is a bad character, but 08 might not be a bad character because 07 being a bad character might have caused 08 to fail, right? And similarly, 2E might have caused 2F to fail, and A0 might have caused A1 to fail. So now we just have to keep running this through step by step, one thing at a time, and identify which of these are in fact bad characters, okay? And so the next step here would be to, let me just go back to the CPU view here and maximize this again. So the next step would be to update our byte array binary to include all of those characters that are bad characters, right? So we can come, where is it? And some noises in the background, so apologies for that. But what we're going to do here is we're going to actually rerun this, except we're going to say, to save time, I'll run all of these at once. All the ones that seem like they're bad characters, but really the faster way, or the more methodical way would be just these two, and then run it again, just these, and then run it again, just these. But just to speed up, save some time, I'm going to run it like this. So I come here, and I will plug in all these values here. So we're saying, hey, assume all 4 of these are bad characters. Now what you'll notice is, we said 7 was a bad character, so it goes from 6 to 8. And so on. And you see like 2E will be gone as well, and A0. And so now we have our updated byte array. So now we also need to update that in the script. Okay. So we need to remove 07. We need to remove, we can do a find, right? 2E, right? And A0. So we remove all of those, save it, and we're going to have to restart the program. And let's just verify connectivity. And not able to connect. Oh, right, because I didn't hit play. So, yep, this is why I always verify connectivity here. And now we should be able to run this. We crash the program, make a note of the stack pointer. Don't assume that it's the same. We'll just copy this value here. And now we will go ahead and paste this in. And definitely save these steps to your notes if you guys are following along, because this is a process, right? So you can repeat this on any Windows buffer overflow machine. So the main takeaway here is this is all just a process that you can apply across the board. See, once you've identified all of the bad characters, you'll see status unmodified. So this is what you want. Like, this is the ultimate goal here. So now we have successfully identified these are the bad characters. There's 4 of them. Okay. And basically that's what they talk about somewhere in here. Yeah. You want to keep going until you get this unmodified, like so. So now we know we've identified successfully all of the bad characters. So the next thing that we need to do is identify the jump point, okay? And basically this Mona script here will look around the entire executable, the entire binary, and find an instance of where jump ESP is used, which is going to jump to the stack pointer, okay? And so if we can find one where we can use it and there's no like protections against us, no restrictions for us, we can use it, then we can use it to jump to malicious code to say connect back to our listener. And that's exactly what we're going to do. So if we go to the CPU view again, we should be able to run it here. And, we need to pass it the correct list of bad characters because it needs to find a jump ESP that isn't utilizing any of the characters that we said are bad characters, right? And so, shoot, it didn't open up the window. It is log data, I believe. Yes, log data. You see there's a number of potential ones we can use, right? The big thing is we want to make sure there's no ASLR, rebase, safe SEH, OS, any of these protections. They're all off. So in this case, we have a lot of different options we can use. We can use any of these addresses, any of these memory addresses. In this case, let's just go with the first one here. Copy to clipboard address. So we're going to use this address. And of course, we need to write it in little endian format, which that is kind of like reversing it, but not entirely. This is what it looks like. So, as you see here, AF 11 50 62. That is the little endian format because this is big endian here. And we'll need to provide the memory address in little endian format. So that's how you do that. And then from here, we can go ahead and generate our payload. And they give us the MSF Venom command for that to save us some time here. We gotta modify this a little bit for our situation. But basically, take a look at my current IP address. And this is what I'm gonna set for the L host. We can keep the port at 44444, and this is really important here. It's going to make sure that it doesn't crash it every time we run this, right? it'll stay open and we can run our commands. So very important you have exit func equals thread here. Now we're also going to need to modify this to account for the other bad characters that we identified. And we're going to actually save this as a C file just because it's a little bit easier to work with. And this is basically the output of this is what is going to go into the payload. So even though we're saving this as C, this was explained in the walkthrough here, but even though we're saving this as C, or maybe it was in the video done by Tiberius, but basically we're going to use it within our Python script, but it's just, the format that it outputs here is just simply easier to copy and paste over. So that's why we're opting for this format here. Go from here to here, copy it, and we're just going to dump this in the exploit. And the only thing that I forgot about is I need to actually encase these in parentheses, right? Because we have multiple lines of strings here. So we want to make sure that it knows that they're all part of one payload variable. So doing that should rectify any issues we might have had. And so we do that, we save it, and we rerun this, verify connectivity with the netcat command here. And then should be able to go ahead and run that exploit a second time. And now when we go over here, we see we do have a shell on the box. So we can see who we are. We are admin. And yeah, it's pretty much that. I guess simple might not be the right word. It is a lengthy process, but if you get the methodology down, if you have a methodology that you're following, right, I think this does an excellent job of teaching you just the steps. Focus on the big picture. Focus on the what and the why. And don't worry about the minutia of it. You'll get it in time. But this is like your template, the general flow, your general methodology that you can apply to any Windows buffer overflow. And there's certain complexities. You know, this is a very simple one, right? Maybe there's more bad characters, or it's trickier to find a jump ESP that doesn't have any of those protections on it. That, maybe you have to play around with the padding and the size of your shell and all that stuff because you have limited space for a shell. There's different things like that. And there's always more complications, but for the most part, this is the methodology that you can use. Now, as you see, I haven't really went through these other overflows. I'm going to, as I prepare for the OSCP, if I see any of them that are very noteworthy and like, oh man, you guys are really going to need this, then I will definitely make another video covering that for you. But yeah, definitely an excellent place to get started here. Hope you enjoyed my two-part series here on buffer overflow, Windows buffer overflow, what you need to know for OSCP. If you're looking for more content of what you need to know for OSCP, definitely check out the videos that will be on screen now. And yeah, be sure to subscribe to the channel if you haven't already and hit the like button to help get this message out there. And I will see you guys over in those videos. Thanks for watching.